It's a full HD camera that withstands 350 degrees. It's a cool location. I like it so much. Cool.
Always say cool.
Cool.
Scared?
Hi, Pro Robots in Voronezh, Russia. Today we will show you the production of the company Intechros, which makes these giant robots. What are these giants for? How are they created? How do you manage them? Today, we will answer these and other questions. And we're going to try these robots in action. Let's go. Ratibor Konovolyuk, Development Director at Intechros, will show us the production and tell us about the developments of Intechros. Hi, Ratibor.
Hello.
Come on, in a COVID style. Well, let's go watch.
Let's go.
This is where all the production starts, right?
I would say that this is where the robot begins.
Robot?
Because everything comes to us at the sheet metal level and comes out in 10 months as a certified serial product. So here it is. Well, getting ahead of ourselves. That has passed the development stage and everything else. The production starts here. We acquire the metal and, accordingly, all of this is further transformed through many operations into complex technical products. In a robot, on average, there are over 10,000 parts, and it starts right here. Today, robots are also made by robots. We in particular use a welding robot in our production, so of course this greatly increases both labor productivity and welding quality. So I think sooner or later all our operations will be transferred to it.
Roboticized.
Robotic assembly of robots. That's what we should strive for.
Of course. Tell us, how and why did you start to develop and produce such robots?
It all started more than 20 years ago. We specialized in hydraulics, mechanics, and in general, we dealt with simple hydraulic tools. But literally 5 years ago, we realized that hydraulic drive has changed. Electronic systems have been added, i.e., we can make smart machines based on automation of the hydraulic drive. So today, we came to the point where we are developing new things based on hydraulics. Robots are like one of the main applications, actually, of multifunctional stories. We realized that we don't just need to make automated stories, but they need to be applicable in a wide range of industries, and robots are already a natural development of this idea.
Tell me, is it somehow difficult to do automation in relation to the hydraulic drive? And what is the complexity itself?
Yes, there are some nuances related to the automation of hydraulic drive. First of all, there have been no developments in this direction for a very long time. And most of our work relates to avionics. And in terms of hydraulic drive robots, which we refer to, it is more at the level of excavators and earth-moving equipment. In this direction, of course, everything was abandoned long ago, and vacuum was formed in such developments.
And what kind of unique machines do you develop for?
Well, basically, we're concentrating on 6 areas right now: nuclear, construction, railroad, oil and gas, mining, and metallurgy. Here, the same robot going through a deep upgrade, assembled from modules like a construction kit, is used for either metallurgy or, for example, in demolition in the construction industry. But conceptually, it will always be our hydraulic drive as a rule, because that is our main specialization. But in each of these industries, they find new ones, which means that, on average, each robot has 10 types of attachments that it changes in the process.
Tell us more about these guys who are here.
With pleasure. Actually, we have here the heaviest platform that's available to us today. This is the TPM. We call it the 1000th platform because it weighs about 10 tons. It has a rather specific narrow task: extinguishing gas and oil wells. There is a big problem all over the world. Well accidents happen. They are associated with malfunctions, or some natural disasters occur, but the result is that we have a 50-meter fire, a 50-meter flare burning the ambient temperature of 350 to 400 degrees, and a complete loss of control over the well. Accordingly, it is done today or manually with the help of protective mechanisms. At best, some of the special equipment like excavators or cranes are used.
And this is the model of how it happened in action, right? For extinguishing oil wells? Tell me more about how this robot works.
Here, on the model, there is already, in fact, an actuating mechanism by which this happens. This is just to the question of how we customize. Globally, the platform itself is prepared for use in industry. You can put a manipulator on it, some firefighting equipment, but for oil and gas in particular, we put a shutoff and wellhead assembly on it. Accordingly, the robot drives up from the hot well, and with the help of a hydraulic winch can pull some of the large pieces of the metal structure, prepare the well for extinguishing to the condition of, roughly speaking, a pipe sticking out of the ground. Out of this pipe, though, there is a big flame, and it is necessary to do the job promptly somehow.
And how many degrees approximately should the robot be able to withstand?
350 to 400 degrees Celsius.
Do I understand correctly that this robot was already on fire?
Exactly. It has been in combat conditions. It was tested at the military range in Oxtron, just with a real borehole, with burning it up, and it is here in pristine condition. We did not paint it afterwards here. The interesting thing to note here is that the heat shields did not stand up to the test. They got burnt. All the paint is special, heat resistant, even in chambers to withstand 350 to 400 degrees. The hydraulics are in this thermal protection braid. In other words, the entire machine from head to toe is prepared to go through a fire, and it has to survive enough time to set up the locking and wellhead assembly, which means that it has to survive critical temperatures for around 10 to 15 minutes, because if the robot stands next to the well with the wellhead assembly, that's it. It's just another piece of scrap metal that will have to be pulled out of there somehow.
Tell me, do I understand correctly that this is actually the control panel for this robot?
Yes, it's a technological remote control for the short-term movement somewhere. In general, the interesting thing with the remote control is that it is essentially needed to move somewhere in a small area, because the operator, of course, is not near the machine. The operator controls everything through cameras. Today we provide a control range of 1.5 kilometers, which means it can be very far from the well.
1.5 miles?
Yes.
And by what means of communication? A picture? Or what parameters are transmitted at all?
4 cameras, 3 in the front and 1 in the back. The cameras are in full HD resolution, and it's all transmitted by a special directional antenna. So the important point here is that there basically are 3 configurations available in terms of communication range. The simplest one is with such an antenna.
It's a simple remote, isn't it?
Yes, he's at 300 meters.
Is it 300?
Yes, the standard one. When we get to 1.5 kilometers, then there will still be a special directional antenna near you, which will amplify this signal for the robot. Another important point is that the robot does not need any additional special equipment to unload the well. In fact, such triggers are installed literally in the field on each of the 4 supports, and it can unload itself from the truck on which it arrived.
Tell me, what is the payload capacity of this robot?
Well, actually, it can lift 10 tons, so it's not difficult for him to use any equipment, and us too.
So we're here now, well, I guess how much? 100? 130 kilograms?
130, yes.
Well, shall we test his strength?
Come on.
It seems to hold up.
It's okay.
This is the robot Roin. It's also a mobile platform with a big claw like this. Tell me, what is the robot for?
Roin is rather a family of platforms. That is, today we produce about 4 to 5 platforms on which the manipulators and actuators change separately. Accordingly, this is the middle version, the 300th, and it's used in absolutely different guises. For example, with this claw, it can be used to replace sleepers on the railroad. In tunnels, then it's mounted on the track chassis, but on the railroad platform. Another application, we threw away planned manipulators and got bored with it. We can use it as a transport vehicle. Instead of the manipulator, we put a body on it with dozer blades. There is a big moldboard for clearing snow or clearing shrubbery and bushes, and it's already a transport machine, which moves something. And as a rule, the main consumer of such machines is nuclear industries, and they use it in radiation-contaminated environments, which means that it's all protected with radiation-resistant protection. All electronics are in lead cabinets, special radiation-resistant chambers. They work with radioactive objects. So, one vehicle with a manipulator picks it up, another vehicle with a similar vehicle and body, one next to it, puts the radioactive object on it, and the other vehicle leaves on its way. So there's a unification in terms of platforms, but it makes absolutely different sense depending on which actuator is actually used.
What's the grip right now? What is it used for?
Specifically, this is a sleeper gripper for gripping sleepers. It's mainly used in the railway industry, wherever there are sleepers.
Is this your design?
Yes, well, we did it, roughly speaking, in a half day. For us, it's a perfectly easy knot. In fact, the complicated one, on which we had to work a lot, probably for several years, is the tilt and turn device. It replaces the human hand on all of our robots and excavators, because it provides 360 degrees of rotation of the equipment and a 45-degree tilt. Plus, it has a quick release mechanism that allows you to change this attachment.
Can I change it automatically, or does it need a person?
Today, there are 3 options available. The simplest one, of course, still with the use of mechanical labor. The most complicated one is already in full synchronization of hydraulic lines. That is, as we see it, we have hydraulics on the attachment that have to be connected by hoses. So, if you have a radioactively contaminated environment, it's very difficult or impossible to do that at all. Accordingly, there are quick release mechanisms that immediately synchronize the hydraulic lines and eliminate the human presence in the hazardous area, so it can be done automatically today.
And this is the process of assembling the largest robot, Roin 700. Tell us, what do you actually assemble these robots out of?
By default, since we are, after all, a domestic company, we, of course, often out of a sense of patriotism, try to assemble from domestic components. But there are a number of things here. That, for example, hydraulics are not available in our country. That is, they're very poor quality products. But nevertheless, by default, we try to use a domestic electric motor, a domestic reducer, a domestic pumping station, and today it is, in principle, affordable. But our customers often give specific wishes on foreign manufacturers, and that's why it's such a struggle for a search for compromise to what we use.
Tell me, how long does it take you to develop and produce?
If the topic is completely new to us and not standard even for the industry, then we take about 10 months from identifying the problem for which we need a solution to producing a serial product, that is, to the machine being certified, allowed to work, and so on.
And who will this robot go to?
Specifically, this model's for us because it is an educational robot. We needed to train every operator to operate our complex because, as you understand, operator of a robotic complex, there's no such profession yet.
A complex like yours because you actually develop it.
Yes, that's why we got a license to conduct educational activities.
And tell me, what knowledge and skills should an operator who comes to you for training already have? Does he have to be an engineer, or can he be, a humanitarian who wants to try his hand at this field?
Secondary technical education, I would say so.
Secondary technical.
Such an education at the very least, because ideally, of course, if a person has an understanding of the basic principles of hydraulics and mechanics, it will reduce the time to explain. But globally, of course, it doesn't have to be an engineer at all. Moreover, as for the age limit, many times we try to put there to be an experienced excavator operator, such a 50 plus, and it was always a failure. That is, the guys who played space shooters and worked on joysticks, cope much better and faster and immediately get into the subject, but they have the opposite theme with maintenance. If old-timers understand how mechanisms work, they serve better, but control worse. That's why we, in fact, even as a part of our education, try to differentiate. We ask the customer right away who we'd like to train as a service technician and who we'd like to train as an operator, because different people have to operate and service the equipment.
Tell me, why is he white? Where will his robot go?
It's the customer requirement, of course, that he should be white, probably because he's going to be beautiful and clean Europe. Specifically, this machine here is on maintenance. It's used to maintain high voltage power lines, specifically in the city of Riga. So, much machines are now planned to be actively used just for these works. Anywhere there's a large infrastructure, geographically distributed, the railroad tens of thousands of kilometers, high voltage lines also tens of thousands of kilometers, pipelines also tens of thousand kilometers, they all need to be serviced, but there's no possibility to keep excavators or any special equipment every 100 meters. It's enough to take 1/700th of a complex and 10 types of attachments, and you can do the whole range of engineering works, and that's why RON stands for Robotic Engineer. That is, a robot for engineering work.
To perform various engineer tasks. Great! Well, you don't just make robots, do you?
Of course not. Our solution, in fact, allows us to use them in very different industries. The customer comes to us because we know about hydraulics. Here, for the subway, there is a request for a station service or a very simple one. It had to fit into the turnstile, and it has just the same width as the door that it came through. This elevator can go through that door, powered by any outlet.
This is the elevator, right?
Yes, to power from any 220-volt outlet, climb to a height of 9.5 meters and do some work. Here an important point remains. We are the only manufacturer of such elevators in Russia, and in the world it's also a very local niche story. This, in my opinion, is our specialty, because we seek out these unfilled technological processes that are not mechanized, not roboticized, and not automated, and we try to fill that gap with our hydraulic-based solutions to completely exclude humans even from such a seemingly simple area as maintenance of contact networks. In particular, the most unusual client was probably a paleontological museum for dinosaur maintenance, as unconventional as that may sound.
And this, then, is the control panel for this elevator.
Yes, that's about it. We have a redundant system here, so the operator can control the cradle, and if suddenly lost consciousness and, for example, press the stop button, then everything technically cannot be lowered from the height, and the height can almost be 10 meters. Respectively, the second person can do all this from below as a means of hydraulics and electronics, switch the control, and the circuit is fully redundant. And if suddenly the electricity runs out, there's a built-in manual hydraulic pump. That is, in case of complete losses of power, the person can still be lowered, respectively excluding a situation where the person is stuck in the cradle. Moreover, he will not be able to get up and start the work if the trigger supports are not fully spaced, because each gate is necessarily equipped with a ring sensor. For every piece of equipment, we try to figure out how it can be broken, and that's where we start from when we think about how we can prevent it from being broken. Accordingly, even with such a simple product, there are 3 or 4 systems that protect against such emergency situations.
Yes, and help make it safe for operation.
Yes.
Cool.
Since we have a lot of hydraulics, accordingly, all of them must be tested. That is, when we have an assembly. Hydraulics in this respect is a dangerous story. For example, the pressure is very high, and an accident can happen, including fatalities. So when they test the system, they always try to do it with gloves and safety standards. Due to the fact that our series is small, we can perform a complex total check. Every hydraulic cylinder, every hose, in general, all elements are tested on the stands 100%, which allows us to keep the quality of products. But in fact, it's more profitable for us too.
What are those things?
These are, in fact, brushes for excavators. That's the small version we saw on the robots, and this is 005. It's called the till rotator, and in Europe, it's been sold for a long time as the till rotator, just an upgrade to excavators. But since we are trying to automate everything, we can reach out with our hands. We install the till rotator for a large excavator, and then we add digital assistants that make the operators work easier and simpler. This is for a 20-ton excavator, which is already quite big machine with a great capability. If oil is our blood, then this is where the vessels through which that blood travels are collected. Again, the hydraulic cylinder we tested is very cool, but if you have, roughly speaking, a good motor, but a bad vessel, you will lose blood, and there will be no useful work.
And what can your biggest robot do?
The older series is now the 700 series, excluding some special series for oil and gas. So, the 700 model is so called because its lifting capacity is 7 tons, and that it has a quite large modularity in terms of what it can be installed on. It is usually a railroad platform or a truck. Plus, our favorite versatility is any kind of attachment. 9 to 10 kinds are used on average, and there are cool features in the form of lift heights. In particular, the 700 series has a lifting height of 16 meters, which is about 5 floors, so you have to bend over a lot to see where the attachment is.
Wait, that is 700 tons?
7 tons.
7 tons. 16 meters. So he is the one who can lift 7 tons up there.
No, of course, 7 tons. It goes in the working area near the machine. But at the end it lifts a ton, 16 meters, because the attachment just on average weighs 500 to 700 kilograms. In order to be able to manipulate it, here comes a small reserve on lifting capacity. Here. But we calculate just the benefit like that. We have a special project for dismantling the nuclear industry, traditionally a dirty place. We have to dismantle 3 stories from the top, 2 stories from the bottom. In fact, one machine has to come up and reach both the bottom and the top, so such large outreaches are critical to us.
Cool. The robot behind us is controlled by this operator. Tell me, if it's controlled by an operator, why is it a robot?
Well, actually, we can go by the degree of automation to the understanding of the robot we started. Of course, with telemetry, in order to control remotely, cameras are added for visual control and sensors are added. Technical vision is added. We are gradually, step by step, moving towards full automation. But that's probably what makes hydraulics different today, that it lags far behind electric drive-based systems, that very little has been done in terms of automation. That's why, in order to address the issue, we opened a laboratory in our home region at Verona State University. This laboratory is studying which machine learning tools can help us. We tried the Bayesian algorithm, we tried Q-learning, and today we have learned how to partially automate, that is, how to make digital assistants from our operator. In particular, here, each trigger has 3 degrees of freedom, and that's either a lot of leverage or a lot of time to put the robot together. 4 supports of 3 degrees. Accordingly, today, our heaviest complex can fold and unfold in 1 minute.
Through artificial intelligence technology?
But this can be implemented in its own simplest form, even without machine learning. But let's just say it makes the task more difficult. Our clients, of course, like to give us the most interesting tasks. A limited space, we need to understand where we are and understand what position the manipulator is in, and calculate the best possible algorithm for the safe transition from working to transportation position. This is where machine learning comes in, because it's not always possible to put sensors around the manipulator itself. I mean with technical vision in the form of radars, lidars, and video cameras, because it's trivial to say that 20 grays per hour, the radiation power can no longer withstand such sensors, and they cost a lot of money, if they exist, or they may not be supplied to our country at all. So on one hand, we try to use simple solutions, simple sensors. There's a bankometer and linear movement sensors. But we also try to use more complex algorithms so that they can do their job with the minimum amount of data. Telemetry, digital assistance, I hope will come to the point where the robot itself will drill.
Can you do it in 5 years?
I think it's easy, because if you put into these supports and these triggers so that it already moves itself, but you have to teach it to do it.
It's a Roin Robot with a hydraulic breaker, right?
Yes, that's right.
And it's used for dismantling?
As a rule, yes. Generally, all over the world, this type of hydraulic robot is not called engineering robots, but it is disassembly robots. In fact, this market only in Europe amounts to $234 million, growing every year by about 16 to 20%. In general, this is due to increasingly complex requirements for noise, safety of work, and there's simply no alternative today. It's forbidden to dismantle concrete structures with their hands. And not so long ago, we brought in a junior model where we did dismantling work. And on average, roughly speaking, it does in a day what a person or even a team would do in 7 days.
Tell us, what's under the hood of this baby?
Actually, there's a lot of hydraulics. There's a diesel motor, but also always in the process of setting up a robot test, you have to adjust things manually and often. Today, you're going to be our adjuster. So here's the key. We have to direct access to the main parts of the hydraulic system, in particular, all the hydraulic control valves here. So take this bolt here. Yeah, on the other side. No, look, it doesn't fit.
See, I'm not an expert at all.
Yes, turn it a little bit, 10 to 15 degrees.
Like this?
Yes, now you have increased the pressure in the hydraulic system to 200 atmospheres.
And before that?
Before that, it was about 150. The point is that in a car tire, you have 2 to 3 atmospheres at most, which means you can roughly imagine what the pressure in the hydraulic system is for the robot to work. At this pressure, in fact, the robot will need maximum power here, and you need to use some heavy equipment. You can already let go. It will not break. When you need to use heavy attachments or high outreach power, it lifts thousands of kilograms at maximum too. So, and when you need the operator to do something heavy, he quickly adjusted, got the pressure in the system in the standard. Let's go back to working our 150 to 180. That is the standard mode in which he will work for a long time.
Look, there's some kind of signpost for dummies missing.
And here, in fact, there's a point that, as a rule, we try to adjust the system initially, from the factory so that it does not have to fix anything at all. In other words, we ask in advance what attachments are needed so the person does not have to go in there as much as possible. It's better for everyone to stay out of it.
I'd better not be allowed in there. Can we go deeper?
Yes, up to 10 to 15 centimeters.
Oh. How big is your production facility?
Now we have about 6,500 square meters of production area available. In fact, all this space for the most part has appeared in the last 5 years, because in my opinion, it's connected, of course, strongly with the reorientation of the company and the product. If before, in fact, we didn't need that much capacity, we were doing small hydraulic tools, small mechanized tools, which required small production areas, small number of personnel. Everything could be done, conventionally speaking, by 2 design engineers, 10 locksmiths, and it was easy. But our desire to do something new, complex, and functional led us to robotics, and it pulled, like all the strings, a new paint shop, a new assembly area, and all the assembly and testing areas, and so on.
How many employees do you have now?
About 100 people, a quarter of them are from the design bureau.
Is there a need for some new personnel? Where are you hiring, looking for some new young specialists?
Now we have come to the understanding that we need to nurture them, literally from the school bench, because there's almost no training for robotics as such in the country. And we are the general sponsor of RoboArt, the Festival of Robotics, and accordingly, we instill and show that there's such a company in Voronezh. And then we hold open days. The laboratory in the State University allowed us to open a new area together with the university, which is Robotics and Mechatronics. That is, even the program itself has already been formed by our specialists together with university professors, and we will focus and advance. I, in particular, have a robotics education. There was little attention paid to hydraulics. At the university, we want to do robotics with a focus on hydraulics and train specialists, but this is a long time, 3 to 5 years or more, so we need to reap the benefits in a happy future.
In 5 to 10 years, probably.
Yes, I think so. We will still have a lot of interesting things to do, so we'll manage.
Tell me, what kind of workshop is this?
This is basically where the precision machining takes place, the machine part. Not all machines are represented here, of course, but in particular, behind us is a 3-meter long lathe. That's actually why we need such big machines, and that's a pretty big length in general, because the complexes I showed, they are big, and the hydraulic cylinder on it too, accordingly, has up to 3 meters. So you have to hold such a machine. By the way, this machine specifically, and its neighboring companion, was purchased with the help of a subsidy with the help of innovation promotion funds. We took advantage of the commercialization program. Well, my personal feedback is that I have not seen these people. I do not know where they are even temporarily, but they gave us enough money to buy 2 machines. The company and the program is 50-50, but still was all super transparent online. I personally have only positive impressions that we will continue to use them.
Overall, you have support in your case. Did it work and did it help you?
Actually, I would say yes, and I personally supervise this project, and I could follow all of the nuances personally. It seems to me that there's exactly 2 or 3 instruments that work safely, and now we're going to analyze. We opened a regional industrial development fund, which has also kind of facilitated our access to these funds, because we do not attract outside investment. We develop all investment, new workshops, and everything only from our own funds. These are the methods of state support that actually allow us to try something new, roughly speaking, even newer than what we normally do. Nevertheless, the production base allows us to increase. For the most part, from the state, of course, the request is not to interfere, but nevertheless, working measures of support also exist. Well, actually, we assemble everything here. We program it ourselves. We assemble the consoles ourselves. This is the production area where the electronics are assembled. That's how our staff selects consoles and installs them, programs them, and sews them. Today, we create control cabinets separately, directly for water treatment plants or any industrial systems, because we already know how to operate them, how to use them, so we can assemble anything separately, by and large. This is where all the magic happens.
We have a little present for the subscribers of Pro Robots from Intechros.
We have a lot of interesting things there. A power bank, a t-shirt, and a power bank for fans of engineering robots. The Intechros mouse and notebook for the best suggestions. And all this wealth will go to the person who proposes an unusual application for hydraulic robots. Because today we work in 6 industries and we're already tired of losing count of where else they can be used. We are interested in your opinion. How can we use our hydraulic robots?
Write in the comments your ideas about using Intechros robots, and you will have a chance to get a gift from Intechros.
We are very interested. We will wait for your suggestions.
And that's how we ended up visiting the company of Intechros. I really liked both the robots and the production. I was very impressed. If you have any questions, write them down in the comments. Be sure to like this video and share it with your friends, and see you in our next video.